Finished.
All right, so for the first one here, if we're going to factor that, this is a quadratic. That is, we have the x squared in there. And it's one of those where we have the x squared and the x. What that tells me is that any time I see both x squared and x in there, that I'm going to factor it into two sets of parentheses. Remember where we do it looking like that. And each of those two parentheses now is going to get a number. I know what those two numbers are because they're the two numbers that add to the middle number, -9, and multiply to the last number, the -36. So I think about, okay, what multiplies to 36? And there's a few different numbers that you might think of along the way, but in this case, the one that we actually care about is -12 and +3.
What if you did -3?
All right, the second problem here. The second problem doesn't quite look like that though. Notice the second one, it starts with x cubed and then it goes to x squared and then there's no x's. And so how will we do that? Well, we're not going to end up with the two sets of parentheses like we did in the first one. Instead, what we're going to do is we're going to just pull out one thing that I can divide everything through by. Because you'll notice in the first one, I couldn't divide x squared, 9x, and 36 all by the same thing. But I can divide all three of those by the same thing.
5.
Yeah, 5. And so what I'm going to do then is I'm going to factor out a 5. This is actually a factoring technique that we did before this type, but it's probably gotten a little rusty. Okay, so I know I can divide everything through by 5, so now I do the division by 5. 30 divided by 5 gives me 6, so it's 6x cubed. Because I'm not pulling out any x's here, that's going to change the x's. Then 40 divided by 5 is 8, so that's 8x squared. Plus 15 divided by 5 is 3. And so really what we're doing with this style is just distributive property backwards. All right, now for this last one, this last problem, well, this is where things get interesting for us here. Because I do see that I have x squared and x. But whenever we've done this kind of factoring up here, we've always had to start with just a plain old x squared. No number in front of it. And so I'm actually going to start by looking to see if I can divide something out like I did on this. So is there anything that I can divide out of the 4x squared, the 36x, and the 80?
2.
Yes. 2 does come out, although there's actually something bigger.
4.
Notice 4 even comes out of all of them. Let's see what that gives us. And again, we're doing this all without calculator. Well, we start by writing down the 4, because we always want to note what I'm dividing out of everything. And if I do 4x squared divided by 4, well, 4 divided by 4 is 1, so the number goes away. I'm just left with the x squared. Because it's 1x squared, which is x squared.
Oh.
All right, then plus, stays a plus there. 36 divided by 4 is 9, so that becomes 9x. Plus 80 divided by 4. And yes, I'd expect you to do this without your calculator. Mostly because
20.
80 divided by 4, 8 divided by 4 is 2,
I'm ready.
and 80 divided by 4 then would be 20. Yep, very good. All right, now having done that, I used the same process that I used here to get that answer. But, this is our new piece for today. Notice that the resulting quadratic that's inside the parentheses, that looks a lot like this type up here. And in fact, I can actually go further and factor it that way. So that's what we're going to do next. So my next step then, the 4 is still out front, but I'm going to end up with 2 sets of parentheses following it. And I fill in those 2 sets of parentheses the same way that I filled it in the first one. I'm looking at the quadratic that I just created in here, and I'm saying what 2 numbers add to the middle number and multiply to the last number. So adding to 9, multiplying to 20. So we think, okay, what multiplies to 20? And I start cycling through all of those till I find a pair that adds to 9. Hopefully you come to the conclusion that it is 5, and 4.
Yes.
And this then would be our completely factored form. This is basically what we're doing today. Is we are just taking our factoring that we had done before of a quadratic or of just any polynomial and combining those skills into being able to factor much more complicated quadratics than we could have done before. All right, so for this one now, again, we're going to approach it the same way. Now, you'll notice here I got the x squared and the x again, which makes me start thinking about the two sets of parentheses. But again, it's not starting with just plain old x squared. And the technique we have means we got to start with x squared. So if I want to make this just be an x squared, what would I divide it by? It won't be 2, it will be -2. The sign is going to go with it. So in this kind of case, we're actually going to divide out, or factor out, more precisely, -2. Now by doing that, yeah, we get just plain old x squared here, but next term, the plus 30x is going to change. 30 divided by a -2 gives me a -15. And so if I do 30 divided by -2, then that gives me a -15. So that's minus 15x. Notice our signs changed.
Why are we doing division?
Because we're factoring out. We're factoring out that -2, so that's division. And then the -100. If I pull the -2 out of -100, that leaves me with a positive 50. Yes. And notice we really are just using distributive property backwards. If I multiplied this -2 back into all three of those terms, I would get what I started with. So that's why we can think of it as dividing out the -2. Now having done that though, I'm not done. The -2 is out front, but I can now break this up into the two sets of parentheses. So we now say what two numbers add to -15 and multiply to 50. Well, I made them nice, easy numbers to do without the calculator, right?
I got this.
So we end up with -5 and -10 there. All right, now for this one, again, we have to look at it the same way. Now, it's tempting in this case to think there is no number in front of the x squared to pull out. But it's also not just a plain old x squared here. It's a -x squared. And I need it to be just a regular old x squared. Well, remember that -x squared is the same thing as -1 times x squared. So there is a number there. It's a -1. And I need it to be a positive one. And so what we're actually going to do is we are going to factor out a -1 out of this whole quadratic.
Done.
Now if we do that, that just effectively is flipping all the signs. So like a -x squared divided by -1 becomes a positive x squared. A -x divided by -1 becomes a positive x. And a positive 42 divided by -1 is a -42. Now, I gotta say though, as a math person, that -1 sitting out front of the parentheses kind of makes me twitch a little.
Same.
I don't like that -1 there.
Is that another problem?
It can be simpler. And so rather than writing -1, we can just go ahead and write that as negative parentheses. Because it means the same thing. And so, yeah, we just put that negative out front. Because that means -1 times the parentheses. Okay, so now, next step. The negative is still sitting out front here. But I got a quadratic inside, so I can go ahead and factor that. So that's going to become x and x inside each of their own parentheses. And we say what two numbers multiply to -42, but add to a positive 1, because that 1x in the middle, remember? Yeah. And so you should be getting a positive 7 and a -6.